This message is for Setha, who had a question on the Chapter 3 review. Find the limit as theta approaches 0, sine 5 theta over 9 theta. So when I see this, the first thing I try to do is I try to plug 0 in here. So when I plug 0 in here, sine times 0 is just 0. 9 times 0 is 0. So if I plug it in, I get 0 over 0, which does not work. So 0 over 0, nope. That does not work. So that means we need to manipulate something about this function in order for us to substitute the 0 in for theta. So we need to manipulate it. And the key thing is when you see a sine, remember that recall the theorem that we learned in class, that if you have sine of x approaching 0 or theta approaching 0, if you have sine x over x, this will equal to 1. So we learned that theorem in class in chapter 3. And this is true whenever these two items are the same. So it doesn't have to be x. It could be a limit as x approaches 0 of sine 8x over 8x. Since these two are the same, sine 8x over 8x using that theorem is still also equal to 1. So when I look at this here, I see a sine 5 theta. So what I'm going to do is I'm going to manipulate this function so that I can use this theorem. So what I'm going to do is I have limit as theta approaches 0 of sine 5 theta. And this 9 theta, I'm just going to move that across here and do this. So I'm going to break up this fraction into two fractions where one is being multiplied with the other. So remember, you can do this because if I said, if I gave you a fraction, say 4 over 7, it's the same thing as saying 4 over 1 times 1 over 7, right? So you could break up a fraction by having the numerator here over 1 times 1 over 7. So that's the same thing as what I did here. Sine 5 theta, put it here, times the 9 theta in the bottom, put 1 over 9 theta. Hope that makes sense of just splitting up the fraction like this. It's the same thing as that. So what I want, so the great thing about math is that you can manipulate it, but manipulating it according to the rule of math. So here I want a 5 theta. That's what I want. I want a 5 theta here. Because if I have a 5 theta here, sine 5 theta divided by 5 theta, using this theorem, this will equal to 1. So this thing here will become 1. Note though, if I can't just put a 5 theta on the bottom just because I feel like it, I have to do it in a way that's according to the rules of math. So if you divide by 5 theta, then you have to multiply by 5 theta. So I multiply by 5 theta on top there. So again, if you divide by 5 theta, you got to multiply by 5 theta. And this is legit because 5 theta divided by 5 theta is just 1. And you can multiply any fraction by 1 and keep the integrity or the value of the function. So here, 5 theta over 9 theta. So the thetas cancels out. So I am left with 5 over 9. So just a heads up, if you see this on an exam, I need to see the steps. I need to see that you use this theorem by splitting the fractions and putting 5 theta on the bottom, 5 theta on top. I don't want an answer that just says this equals to 5/9 because that will give you no credit because I want to see the work written up. Let me know if you have any questions.